Okay, stop talking, please. Homework from last time. What did you guys do for your first step? We turn this into what? Into cosine. Good. And then what? Secant is 1 over cosine. We get 15. So hopefully you notice this one. There's not an identity we can use square away, right? So I'm probably going to do some algebraic thing first. Does anybody notice any algebraic thing I can do here? Yeah, if I factor out a cosine, I'm left with this. And hopefully you recognize 1 minus cosine squared. That was something, right? What is it? Sine squared. And that's probably as good as you can do. 17 we skip. 19, yes? You mean this cosine right here that's written right there? Uh-huh. You're talking about this one? Well, if I distribute this through, 1 times cosine is cosine, and cosine times cosine squared is cosine cubed, right? Okay. No problems. Again, if you got questions, please shout them out. Okay. Yes. So the idea here is we want to simplify them. So you notice that this starting problem that we had 2 terms, right? And our finished one has 1 term, and there's no way to make that 1 term any simpler than that, right? So that's kind of how we know that we're finished. But the idea is to take correct. The idea there is to take something that's more than 1 term or has more than 1 factor and get it down to less terms or less factors. And in general, we'd prefer something with the least number of terms, even if it ends up with more factors. Like this problem has 2 terms, but they're each 1 factor. Our better answer, though, has 1 term, even though it contains 2 factors. So 1 term and 2 factors is more simple than 2 terms that are each 1 factor. Does that feel any better? Okay. What did y'all want to do first on number 19? Okay, so Sebastian says cotangent negative x can turn into negative cotangent x. And we should also notice that, what else can we do? Yeah, so this one turns into tangent x. Everybody's okay there? And there's some more we can do. Yeah, so negative cotangent can turn into negative 1 over tangent. And now what happens? And we're left with just negative 1. Sure. So this piece turned into this piece. And there was an identity that gave us exactly that. It was one of the, what did we call those? The cofunction identities. I would provide you identities on the on the test, we'll talk about what would be things that would be memorized ones and what are ones that I would give you. The cofunction ones I would end up giving you. Maybe some of the simple ones I might expect you to memorize, like that cosine or cosecant is 1 over sine or something. I think are probably fair to ask you to memorize because you knew those already, hopefully. Okay. Onward to 23. So here we have tangent of pi over 2 minus x times cosecant x all over cosecant squared x. Okay, so pi over 2 minus x, tangent of pi over 2 minus x is cotangent x. I agree with that. What else? Yeah, so notice I have a cosecant on top and a cosecant squared on the bottom. So I could do that as well. Everybody all good so far? Now what would you like to do? So write them in terms of sines and cosines. I like that plan. Cotangent is cosine over sine. And cosecant is 1 over sine. So now we have a fraction over a fraction, right? How do we simplify something like that? This is really just dividing fractions. That's easy as pie. We'll flip the bottom and multiply. And you're left with cosine. Yeah, good job. It's okay. Because guess what we're going to do? The kind of thing we're going to do next is exactly that, where you have the answer and you're going to prove out to it. Okay. How about for 27, ideas on what to do first? Okay, so Sebastian suggests that we can write them all in terms of sines and cosines. That's not a bad idea. There's another way that you could do this, though, that we'll do afterwards here in a second. Everybody's okay with that? Okay, what would I like to do next, assuming that this is the route we're going to take? Okay, sure, and that common denominator in this case would be? Cosine times sine, right? So the first one we need to multiply by sine over sine. That'll give us a sine squared on top. And the second one we multiply by cosine over cosine, gives us a cosine squared on top. Yes. You could have done that at any point. Yep, there's nothing wrong with doing that. No, and the reason, okay, so that is true. That is one of the things. But I want to take a point here and point out that you cannot cancel here. And what's the problem with canceling at this point? The addition sign here, that it's not multiplication. So make sure that you don't make that mistake. It's an easy mistake to make. You get cross out crazy. Yes? So I multiplied this one by sine over sine, and this one by cosine over cosine, so that they'd have a common denominator.
These are candy guns.
Okay. This is not my classroom though. These people are all in B11. You're welcome. Okay, so let's continue on. So we have sine of, somebody pointed out that the numerator of this is one of those things. What is sine squared plus cosine squared equal? 1. And now you can multiply this, and what's going to cancel? And that is, so this was a perfectly reasonable way to kind of do this problem. Although I don't know that it's necessarily going to be the fastest. Is there a faster way of doing this? What if we had instead, just to see kind of a different perspective, what if I had done this and rewritten cotangent as 1 over tangent? Oh, did they? Oh, okay. Well, I want to point this out anyways. So, yeah, that's true. So, good following directions. But if we had done this, would give me this guy. And, oh, I should have done the other way. So what if I did 1 plus cotangent, and then cotangent? So that's 1 plus cotangent squared over cotangent. And 1 plus cotangent, you should recognize, that's something. That's cosecant squared. And so when I multiply the sine in, I end up with sine x and then 1 over sine squared x all over cosine over sine. So I have 1 over sine x on top times sine x over cosine x. So that's me flipping the bottom and multiplying. And then 1 over cosine of secant. So again, perfectly reasonable to do it that way, although you would have not been following directions. And I know that everybody reads the directions carefully and follows the directions, so good job. Next one is 31, right? This is still the same set of directions, I believe. Correct? Okay. Okay, so the direction said to use sines and cosines, right? So let's do that. Tangent is sine over cosine. And then cosecant squared is 1 over sine squared. And then we have tangent again. We already know what that is. And then secant squared is 1 over cosine squared. Everybody's okay so far? Okay. Next up, we will divide these fractions. How do we divide fractions? Yeah, it's easy as pi. You flip the bottom. and multiply. It rhymes, guys. Stop rhyming, I mean it. Does anybody want a peanut? No? Princess Bride, anyone? One person. So now I look at this and it's tempting to say, oh, why don't I cancel these, right? Very tempting to say that. Well, what's going to happen if I do that? You'll end up having to go right back there to make a common denominator on the next step. So I'm not going to cancel them, even though I recognize that I could. So that's going to give me sine cubed plus sine x cosine squared all over cosine x. Everybody happy so far? Okay. What do you notice that we can do to the numerator? Do stuff. So the two terms, I notice I have sines in both of them, right? Yeah, what if I factor a sine out of there? What am I going to have left now? Sine squared plus cosine squared. Ah! That's a good thing. I recognize that. What is sine squared plus cosine squared equal? 1. Which is just tangent. Woo-hoo! I'm trying my hardest. It's Monday and I'm tired. And if I can't try to have a little bit of fun, it's going to be a long 7th hour. My energy level is pretty much spent by the end of the day, so Selena knows what I'm talking about. What's next? All right, so 35, we have sine x over cotangent squared x minus sine x over cosine squared x. Guess what I'm going to do? Well, we could start by making a common denominator. That's not a horrible idea. But what I'm going to do instead is write everything in terms of sines and cosines. Because it seems like that's going to be simpler than making a common denominator, at least for the time being. And maybe I have to come back and make a common denominator still, but I'm willing to run that risk because I think something good might happen here, because that seems like it's going to be a long, painful road of making a common denominator. So I can say here the first fraction is sine x over 1 times sine squared over cosine squared minus sine x over cosine squared x. And woo! Look at what happened. I ended up with a common denominator, man. Sebastian is wrestling with that desk over there, is what it sounds like. Who's winning? Oh. Desk 1, Sebastian 0. Okay, good to know. Is everybody okay with how I've gotten to here? So sine times sine squared is my sine cubed, and then minus sine x. Okay, anybody with some ideas on what to do with that piece? Yeah, I love that plan, but can I make a different suggestion instead of just the sine x? I'm going to factor out a negative sine x. why would I want to do that? Yeah, then I get that familiar identity, right? What is that sine or 1 minus sine squared x equal? And I'm pretty sure it doesn't equal sine. It's cosine squared, right? Again, this thing becomes that. And stuff cancels. We just have 1 minus sine x. I know! I'm excited too. All right, next up is 39. And now we're getting into these factoring ones. So the way I like to think about this is just with a substitution. So I'm going to pretend these cosine x's are really just kind of y's. So this thing then becomes y squared plus 2y plus 1. And I go, piece of cake, I can factor that bad mama jamma. That's just y plus 1 times y plus 1 or y plus 1 squared. And then I can just put the cosine x back in the place of y. And I have a nicely factored thingy-majigger. Everybody okay there? Just as a heads up, like on the test or quiz, would I have to show like this step? Could I just go straight to this thing? That would be okay. You don't have to show the substitution. I usually just like to show it in the notes so that when you go back and look at that, you're like, how the heck did he do that? That it's like, oh, he just thought about it like a quadratic and then factored it. I like to kind of show that. So if you're referring back to things while you're studying, it makes more sense. Oh, this is a good one right here, guys. So you probably looked at this and went, I don't know what to do. That's okay. So there is one good thing that you could do, and it's involving this guy. What is sine squared the same as? Yeah. So I'm going to do that. And then we'll distribute that -2 through. Whoop, whoop. And if we combine some like terms and write this in kind of what I'll call standard form, like we have a quadratic, we have this. It looks very quadratic-y if you ask me. Does anybody else agree with that? Yeah, you should all be agreeing with me. Okay. So if we then say, let's say y equals cosine x, we have 2y squared plus y minus 1. How do we factor something like this? We need to find two numbers that multiply to give me a times c, and then add to give me that multiply to give me a times c, and then those same two numbers have to add to give me b. So what are two numbers that multiply to give me -2 and add to give me 1? 2 and -1, right? So what I can do is I can write this as 2y squared plus 2y minus 1y minus 1. And then I'm going to break this up into two groups. But when I do that, instead of thinking about this as a minus sign, I'm going to think about it as plus a negative, because I need that negative sign to stay with that y coefficient. From that first group, I can take out a 2y, From the second group, I can take out a -1. And you'll notice that these y plus 1 parts are exactly the same. Everybody agree with that? So I'm going to factor them off, and what I'm left with then is 2y minus 1. Am I finished? What do I still have to remember to do? Put that cosine back in place of y. And there's my factored form. Yeep! Mr. Kulik, that's pretty hard. Do I have to do that in the test? Probably not. That's a little bit too hard, I think, for a test question. There's a lot going on there. You have to remember that harder kind of factoring procedure, how to out-yell the weed whacker, you know. Yeah. 1. No, I'm just joking. I'll put it all the way down. Was that far enough? Okay. I was mostly just messing with you. 30% real, though. That leaves the other remaining 70% just mess with. What do we want to do for this one? More math is a good answer. The place where I'm going to focus is this one. And it might be tempting to try to just say, oh, that's cosine squared. And while that's true, it's not very helpful in simplifying this anymore. What I'm going to do instead is I'm going to think about that as a difference of two squares. So that's going to be 1 minus sine x times 1 plus sine x. And gee golly willikers! And we're done. Jeeper creepers, Mr. K, that wasn't so bad. I know, student. What we're going to talk about today is corresponding to section 5.2, and this is proving trig identities. Sometimes we use the word verify instead of prove. Yeah. And they're not so bad because all the tools that we're going to use are just the trig identities from the sheet that we gave you before. So that's going to be our tools. Okay? And it's going to be like an algebraic proof style rather than like a geometric proof style. So let's say that we have the identity tan x plus cotangent x equals secant x times cosecant x. And I want to prove this. So the idea here is going to be, I'm going to start on one side, work only on that one side, and try to make it equal the other side. Everybody okay with that plan? So it's essentially like the problems from yesterday or from last time, but now you're given the answer that you need to end at, right? So it's not too different. The question becomes, which side do I want to pick? And I always want to pick the least simplified side. So pursuant to our conversation earlier, if I have two terms that are one factor each, or I have one term that's two factors, which is less simple? The two terms is the least simple one. That's the side that I'd want to start with. So that's the side I'm going to work on. And I know I'm finished when I get to secant x times cosecant everybody okay with that plan? Okay? Who has an idea of what we should do first? Put them in terms of secants and cosecants. Okay, sure. So tangent is, I think, secant over cosecant. Am I correct there? I have to look at my sheet here. Yes, okay. And then cotangent is cosecant x over secant x. Yep, and I like that plan. So Seabass says, let's make a common denominator here. So I will do that to this one, and then this to the other one. You guys buy that? Seabass now tied up the chair. That answer. Good job. I heard him. Sock it to him. Everybody's okay to hear. I hopes. What do we want to do now? Some more math. Get rid of the squares and I'm done? I don't think so. Yeah. You don't just give up. That's another one for the chair there. I'm sorry, what? Change into sine and cosine? Yeah, that's fine. But if we were going to do that, really probably we should have started at the very beginning, right? So maybe we say give up on this route. And we'll start with Selena's idea here of writing everything in terms of sine and cosine. Hey, guys, here's the here's the thing. Like, it's okay. Eventually, you would have gotten to the right answer even going down that route, but it was going to get pretty gross, and it was going to end up kind of undoing everything you had just done. So this route here that Selena suggested, I think, is much faster to get there. That's why we just kind of gave up on the other one. But it wasn't a bad idea, right? You looked at the answer and you said, oh, maybe if I can just get everything in secants and cosecants, that'll be a good idea, right? And it started looking at it, it's like, I'm not really sure what to do with this. It was getting kind of messy. It's okay to just kind of, you know what? I don't know what's going on. I just brush my hands with this and try something different. That's okay to do. So we did that, sines and cosines. Now what should I do? Common denominator. So sine x and sine x on this one. Cos x on this one. So that's going to give me sine squared x plus cosine squared x over sine x cosine x. And that's looking a lot nicer, right? What is sine squared plus cosine squared? And this is really the same thing as 1 over sine x times 1 over cos x, right? You guys buy that? And what's 1 over sine x? cosecant. And what's 1 over cosine? Secant. And what do we have now? The same thing, right? Well, we did a proof, right? This is the finished symbol for a proof. Yeah. You could write QED there also. That's fine. And it's not like the end of the world. So let's say we want to prove this one. Which side looks more complicated? I would agree with the left side. You have 2 terms instead of 1 term. So what would you like to do first? Me personally, I would make a common denominator first and then look at what I have before I start applying other identities. You're right, but you're way more tardy than I thought you were going to be. So what will that common denominator be here, fellas? Or ladies? So it's going to be secant x plus 1 times secant x minus 1, right? Everybody okay with that? Julia, is that a stretch or a question? Okay, you stretch it out. That chair's getting the best of you. I know. Okay. So, what do you guys see to do now? So we just made a common denominator. Let's FOIL the bottom out. I like that plan. So when I do that, I have a secant squared x, and then I have a secant x, and then I have a minus secant x, and then I have a minus 1. So I like that idea for the denominator. What do you guys want to do in the numerator? That is what we did do, yeah. Hello. Kelly Neapochik. I can't. Help me. What? And Elena Black. That one I can get. Neapokoi. No. What? Can we say it again? Neapokoi. What did I add? Knee. those are empty pockets. So po, and then
Right now.
yeah, me pokoi, because he's po. All right. All right, let's finish this up here. So if I go to the numerator, I add those up. I have 2 secant x in the numerator, right? And if I add the denominator, I have secant and negative secant. Those canceled out. So I see some good things have happened. I have the 2 secant already over secant squared minus 1. Secant squared minus 1 is the same thing as tangent squared. I've rearranged my rearranged the thing from before, and that's the same thing as cotangent. And that didn't match. That's because I copied the problem down wrong. But I guess I'll see you later since everybody's leaving me. Bye.